delay any more then. Thank you, everyone. This is the first of the Distinguished Lecture Series, the kickoff for the whole year. So I hope you'll all sort of make a habit of trying to show up at 1:30 on Tuesdays. Not every Tuesday, but many of the Tuesdays we'll have some really interesting people lined up to come and challenge your minds and intrigue you and get you excited about things. So before I even introduce our speaker, I do want to acknowledge our sponsors. Yahoo helped put this on, as well as the Electrical and Computer Engineering Department helped underwrite some of the costs, as well as our own campus. So they deserve some credit here on that. And today's speaker is Timothy Chou, who is, I just had a really interesting lunch and hearing all kinds of inside stories of Silicon Valley. And so my conclusion after doing web surfing and all is he's basically, as far as I'm concerned, the authority on cloud computing. And I think he's going to be talking about cloud computing today. Timothy got his bachelor's in electrical engineering at North Carolina State and his PhD at the University of Illinois, also in EE. And then his career went from Tandem Computers, which probably many of you have never heard of, but was big in the 80s, non-stop fault-tolerant kind of systems. I actually played on one a little bit back in that time as well. And then after doing various interesting things, he ended up as one of the few people with the title of president at Oracle, where he started their Oracle On Demand service, which was a cloud computing precursor, basically, right? Then he started doing some, he wrote a book called The End of Software, which I think was previewing the fact that people aren't going to be always running software on their own laptop or desktop, but more getting such services off of the cloud, even though it wasn't called the cloud at that time. He introduced actually the first course on cloud computing at Stanford. And in fact, this year's class starts at 4:30 this afternoon for all the Stanford students. So he's taken out a valuable and crucial time of his day to come and speak here, which I appreciate. That class kind of led to his second book, which was called Cloud: 7 Clear Business Models, which you may hear little pieces of today, I'm not sure. And I noticed also just this year, his next book, which is a 3-volume set, got published called Cloud Computing Fundamentals. So if you want to know about cloud, Timothy's obviously the guy who's going all about it. He's lectured all around the world, every continent. He has started a class at Tsinghua University on cloud computing a while back. He's even taught at CMU Rwanda, gave a lecture there, right? So he's covering the globe just as CMU tries to cover the globe. And actually, if I was looking at your Twitter feed, if I can read into that, what his latest tweet was all about, keeping an eye on Africa as the next big opportunity for expansion and business growth. So anyway, so I think we're really privileged to have Timothy Chou come and speak with us here. His talk is titled Next Generation of Enterprise Software and How to Sell It. So it'll be what's next beyond cloud. So Tim, why don't you come on up and I will try and get your talk displayed here.
I just realized I have a clock back there. That's perfect.
Ah, okay.
I don't have to do this.
Now, if I just minimize this isn't working.
Oh, yeah, I need one of these.
Vince? Ah, here we go. Okay. I will, the clicker.
Or do I have to walk
Is this the
everywhere?
clicker? Oh.
Or can I just swipe the board like that?
And,
Yeah,
I didn't
you should
mention
have that.
we may have some remote viewers in Pittsburgh who are also listening. So I'll try
And not in Africa?
and click in. I didn't reach out to Africa actually this time. I should.
So I'll start while he's doing that. So pleasure to be invited here to do a lecture. So what I'm going to do today is I've evolved into building a set of talks. I call them Tim Talks. So they only last 20 minutes, which is 2 minutes longer than a TED Talk, right? So I'm going to do 3 of them today because we have about an hour. And I want to cover three essential things. One, I want to talk a little about business models. One of the things, in fact, this afternoon I will do nearly the same lecture at Stanford. One of the things I've always come to an observation is a lot of folks understand a lot about technology and whatnot, but they haven't spent any time thinking about economics and business models. And I think I have a very simple way to get you at least thinking about this and help put in perspective a lot of what's happening today, which is very much driven by economics. Okay, that's the first thing. The second thing I'm going to do is I like to call it cloud computing for your Facebook friends. So I want to explain cloud computing in a way that can be utilized by people beyond technology people and what the implications of that are. So that's the second thing. And the third thing is I want to talk a little about what at least I think is the next step in enterprise software. So I've been in the enterprise software space for a lot of years, and I've been thinking a lot about this question of what is after CRM, ERP, HR, all those sorts of apps. And I think I now know the answer. So I'm going to share with you at least what I'm thinking about in that area. Okay? Anywhere along the way, please ask questions. It's much more fun for me because, I've heard myself talk. So before I completely get started, and he gives me the right mouse button, or I'll click over there. It's fine. So one of the things, I do a reasonable amount of public speaking. In fact, I was just on Amelia Island doing the kickoff for Aero Electronics. And what I notice if I'm in a room of people is that a lot of people are looking at me trying to figure out why I look like this, but I sound like this. So I grew up in the great state of North Carolina, so if you ever are wondering why I have somewhat of a southern accent, that's why it is. Even though I've lived in the Bay Area now for almost 35 years, but you can't lose kind of the stuff you learn early. So hopefully you'll kind of get that out of your head and just listen to what I'm trying to say. So I titled the talk 10 Lessons for Long Life. I said 10 talks. So I thought I'd start with something more important, which is this is 10 lessons for long life in your personal life. So this actually is taken from a temple in Kyoto, Japan. It's believed to be over 500 years old. It contains the 10 secrets to long life. Actually, some of you guys in here can read this. I do talk to audiences where they're all looking at me like, what is that, right? Okay, so for those of you who have not learned Chinese yet, so here we go. This is the translation, so I'm sure this was true at lunch. You ate more vegetables and less meat. You have more sleep and less worry, more action and less words, and then my favorite, the more bathing, less clothing. So you're kind of wondering, Buddhist monks 500 years ago, right? What were, I guess there was no television, right? So, but anyway, hopefully I will teach you some lessons for your professional life, but if nothing else, a few lessons for your personal life. So I said I'm going to start with business models because it's an area I think that most people who have technology backgrounds have never thought much about. So I'm going to take you through 7 models. I'm going to basically cover what has happened in the tech business over all the past, we'll call it 20, 30 years. I'm going to start with the first model, and I'm going to mostly talk from the perspective of enterprise applications. So what do I mean by that? Financial applications, HR, right, purchasing apps, the stuff that Microsoft, Google, Microsoft, Oracle, SAP all build. Okay, so generally speaking, the traditional model has been to license you software. Okay, so what that meant was I'm going to sell you this hunk of financial software, purchasing, HR, CRM, and I'm going to charge you for the software per user, and this number is actually reasonably close to what you would buy enterprise software at, $4,000 per user. That would be a one-time licensing fee. And then after that, I'm going to charge you for what is called support and maintenance. Support and maintenance is typically derived from the license price, meaning it's 20, 22, 28, 26% of the license fee. So I did the math simple here so you can think about it. So this is just 20%. So 20% of 4,000 is $800 per user per year. Okay? This is pretty much all traditional enterprise application software companies have used this model. Now, just so you're aware of it, this can be an enormously profitable model. So my brothers and sisters at Oracle, right, in the year before they bought Sun, their revenues were $15 billion. How much of that revenue was maintenance? and support? You don't get to answer, Nick. And not you, Nick, that Nick. Any guess? Low. 80, 90. 12 out of $15 billion was that. Support and maintenance. By the way, if you're a business school student, you should realize that the margins on that business were actually north of 90%, which is a beautiful business to be in. In fact, I had Sue Breyer come and do a guest lecture at my Stanford class right when I started it. And Sue made the comment, he says, boy, I would have loved that business model if I could have gotten it, right? It's an enormously profitable model, so you're aware, okay? So I'm going to move to Model 2. So Model 2 is the so-called open source model, which they're actually, every other model I'm going to show you have many different people who have been successful implementing it. This one, not so many, right? So the model is basically this. Hey, I'm not going to charge you for the software. I'm just going to monetize it by charging you for maintenance and support of that software. Okay, so the only reason I came up with $1,600 is because I was just saying, well, you could conceptually charge more than what you charged in Model 1. Okay, so who's the example of success in this business model? Right, Red Hat. So Red Hat monetizes, you attach to the Red Hat network, right, on that line, and you pay them per user, per whatever instance per month. Okay, but pretty much outside of Red Hat, we haven't seen a lot of other great success stories here, but I have it up here for sake of completeness. Before we move to Model 3, many of you may not have spent a lot of time in the work world. What you probably don't realize is that after I buy that hunk of software to automate HR or whatever, right, that's not the end of my spend. It's just the very beginning, right? What I will end up spending once I deploy, forget the implementation of any of that software, forget any of that, but just once I put that into production, I will spend at least, this is actually an old number, today I believe it's much more, but at least 4 times the purchase price of that software per year to manage that software. Okay, 4 times the purchase price per year. So I did the simple math here. So the software costs $4,000. So that means $16,000 per year. If I divide that by 12, right, I'm going to get roughly $1,300 per user per month. Right? Just so you can think about it, in a 4-year time horizon, I will spend 16 times the purchase price of the software. This is an enormous amount of money to do what? To manage the security, the availability, the performance, and the change in that software. So if you walk into any IT shop, and I don't care if you're talking to Bank of America, Fidelity, Target, any company, walk in and ask the CIO, how much money do they have to spend on discretionary things, right, versus they're obligated to spend? You will hear numbers north of 80%. Their budgets are 80, 90% consumed. I have actually talked to customers that are 100% consumed. By what? By managing the security, the availability, the performance, and the change of all that software they bought from all those vendors that you know their names. Okay? So it's an amazing amount of money. Which is why many years ago, the Model 3 came into existence, which some people refer to as outsourcing, which said, hey, let me take your stuff, your mess, and I'll do it for less money, right? Your mess for less is the acronym we used. Right, what did that mean? Well, rather than you spending $1,300 per user per year, I'm going to do it for less than $1,300 per user per year, right? And I coded this, either I'll do it at home, meaning I'll do it at my place. So EDS was one of the very early, they were bought by HP many years ago, but they were one of the very early providers of this stuff. Either I'll do it at my data centers or at customer, meaning I'll take over those computers at your data center. Okay, so those are the two models. And people would just say, I can take over this and do it for less money. This thing became huge in the late 1990s. Does anybody know why? Why was it cheaper? Cheaper because, why cheaper? Yeah. Right, and it was cheaper because what's the cost structure of this stuff? The cost structure is human labor, right? Guys, sysadmins, DBAs, right, walking around, putting in patches, whatever, right? So people discovered that, well, there are these guys in India, right, who will work for a lot less money than these guys in California, right? And so labor arbitrage, which started in the late 90s, really pushed by the advent of the year 2000, caused the creation of a whole bunch of companies that you guys now know about. Infosys, Tata, Wipro, all the giant Indian outsourcers came about predominantly because of this, right? That they were operating with a lower labor rate than you could see in the US. Now, this is why today that idea, everybody uses it, right? So whether I'm going to use China or Bulgaria or Russia or Ukraine or whatever, right? Which is, I'm going to say at the end of the day, put a floor on how much I can reduce this cost structure. So I was introduced, I teach class at Tsinghua and in China, and every year when I go there, I go and drop in and visit either some young startups that are there as well as some of the old companies. So a couple years ago, I was doing a talk similar to this at VMware, right? So VMware has a facility in Beijing. So I said, you guys get paid a tenth what the guys in California get paid? Well, you guys know the answer. No, right? It's not near a tenth. Now, once upon a time, by the way, in the late 90s, it was at least 10 to 1 differences. My belief system is, in the long term, we can't get anything better than a third, right? That'll be a 3x difference in cost structures on a global basis. And pretty much everybody has mined that at this stage. So I like to say, unless I find a group of pygmies educated at, I'll say Carnegie Mellon, I usually say Stanford, but a group of pygmies educated at Carnegie Mellon who are willing to work for $1 a day living in Antarctica, right? I can't take the cost structure down. Okay, there's another flaw to this model. So what is the number one reason why computer systems fail? Us, operator error. There's ample, I mean, go online, you can read tons of reports and stuff about everything from old digital equipment systems all the way up to modern internet systems. We're the source of the failure. Humans, human error, right? This obviously is, I'll just tell you a small joke people will say. How do you build a reliable system? Well, you get a man and a dog. Why do you do that? Well, the man's to feed the dog's to keep the man away from the computer, right? Okay, so this is all based on human labor, right, managing these systems, which means we also have a floor in the reliability of these systems. Okay, so with that, I'll introduce you to Model 4, which is now pretty much ancient history. This is one we developed at Oracle now nearly over 10 years ago, which is we said, hey, you know, you buy the software for $4,000, pay the support and maintenance fee of $800, and then we will manage this for a lot less money, either at your place or my place, right? And so Oracle started doing this. Today, pretty much every traditional software company builds this model, right? Okay, so you should ask me a question right now. By the way, that's how I start my Stanford class. I go, you know, the measure of a student is not what they know, but by the questions they ask. So what's the question? Yeah. Yeah, how do you do that? Did you find the pygmies in Antarctica, right? Okay, no, the answer is no. I'm going to teach you one fundamental idea. So this is the answer. You're all staring at it going, what does this mean? Okay, I promise I will come back to software at the end of this. So how many of you guys have ever read this book, Guns, Germs, and Steel? Oh, this is the erudite side of the room. Okay, so for those of you who haven't read it, it's a book written by a cultural anthropologist named Jared Diamond down at UCLA. It is an answer to a question his friend, who is a New Guinea Aborigine, has. His friend asked him, how come you guys have all the stuff? Meaning, why did civilization prosper in Europe and in Asia, but not in New Guinea? Why did that happen? Well, this is actually a 450-page answer to that question. It's actually got turned into a PBS special if you're at all interested. I'm not going to take you through the whole thing. I'm going to point to one very important thing he says at the beginning. So civilization prospered where we could move from being hunter-gatherers to being farmers. Why? Once we could farm, we could stay still. Once we could stay still, we could specialize. A group of people could make weapons, a group of people could make food, clothing, shelter, etc. And in all the locations where specialization was enabled, civilization prospered. So why do I have an Olympic swimmer on this? So if you want to be an Olympic swimmer, do you swim backstroke, butterfly, freestyle, breaststroke? No, well, unless you're Michael Phelps, right? So you specialize in one of them, right? By the way, do you swim in a 50-meter pool one day and an 80-meter pool the next? No, you swim in the same size pool. Anybody who's done competitive swimming, they count strokes, et cetera, et cetera. Okay, last question. If you want to be an Olympic class swimmer, do you swim a couple laps a day? No, thousands and thousands and thousands, right? Okay, so why do I have, and I realize this is now dated because half of you kids have never even know who this character is. So who is this character? Very good. So Derek Shepard's a character who is a brain surgeon on a show that was called, or is called, Grey's Anatomy, right? So they used to call him Dr. McDreamy. So I said, why is Dr. McDreamy up here? So what is the number one question you should ask a surgeon before he or she performs surgery on you? How many times have you done this, comma, successfully, right? Yeah, comma, successfully. Okay, so let me wrap this all the way around. I said I'm going to talk about software. So I'll tell you a story. This is quite a few years ago. We have a meeting at Oracle with a guy who was the CIO of Unical, at that point in time a large oil and gas company. They have heard, quote, we are managing Oracle apps. He says, oh yeah, we're going to come up, do a nice lunch, courtesy lunch, talk to you guys, and we're going to go home. So we had the nice lunch. We sat in a big, giant meeting room, and Fred looks across the table at me. He goes, hey, you know, my guys manage Oracle apps. Your guys manage Oracle apps. Like, what's the difference? I go, well, I understand why you'd ask that question. I said, I only have one question. How many times have your guys done an upgrade from 11.5.5 to 11.5.7? And he goes, I didn't even say successfully. I just said, how many times? He goes, well, maybe once or twice. I go, can I introduce you to the team who's done it 265 times? By the way, if you can do something 265 times with a human, what should you do? Automate the hell out of it, right? So if I can standardize, right? If I can standardize, in this case, standardize the hardware stack, the software stack, right? The process for doing security patch management, disaster recovery. If I can standardize that, if I can have a group of people specialize in putting in security patches, managing performance, etc., if they start repeating that over and over again, right, I can now turn that into automation. So some of you have been exposed to the words like DevOps, etc. This is all buried economically in the idea that if I can take this and let computers do it, I can crush cost structures, right? It's no longer human labor, right? And, by the way, I took the human out of the loop, so I can build much more reliable systems. And this really sits at the core of everything that's happening with cloud computing, by the way. So I'm going to finish by Model 5. So some people go, well, Model 4 is really not a subscription model because you pay the $4,000 up front. And I go, well, okay. And you know, now many people do this. They basically say, okay, I'm going to bundle this all together. And if you pay this over 3 years, I'll charge you $300 per user. It's just a payment structure more than it is anything about economics, okay? So a lot of traditional software companies have evolved into doing this. Again, letting you choose whether it was at your place or at my place. Model 6 is the one you're probably most familiar with, which is pretty much every business application software company that has gone public since 1999, so since before you were born. I always have to think about, 1999, has been in this model, right? So you're aware of Salesforce and RightNow and Concur, Taleo, NetSuite, SuccessFactors. I mean, I could keep on going, right? Pretty much every business application software company has been delivering in this model, okay? Now, one of the things you'll notice right away is this thing is gone. Nobody lets you choose what server you run your WebEx on, right? My place, your place. By the way, no one lets you choose when you're going to do an upgrade. It's time for the upgrade, right? But in exchange for higher degrees of standardization, I can take cost structures down, by and large by an order of magnitude, right? So now, if you're ever thinking about this from a competitive point of view, right, If I'm the old school world coming in over here, and I get a tenth the cost structures in this model for a class of software, I can take anybody out, right? Because I'm operating with enormously higher margins or enormously higher growth rates. So I'm going to finish by doing model 7. So this is the model which is, in essence, the consumer internet. So these have been called asymmetric business models. So I don't pay directly for using Google search. I don't pay directly for using Amazon or eBay or whatever. I do it by either, yes, monetize through ads, which you're all familiar with, monetize through transaction charges, PayPal, etc. Or the way you can look at it is every time you buy a book on Amazon, you are paying to use the Amazon software. Okay? So these are all asymmetric. Now, just so you can get an idea of the dramatic shifts in economics, anybody want to guess what it would cost if Google were to charge us for using Google search and make no money, so their cost structure? What do you think it is the cost is per user per month? Just to give you a sense of this. This world of traditional software, and it has to do with complexity, is probably about cost structures 50 to 70. Here I can get cost structures $5 to $7. Here we're talking basically about 50 to 70 cents, right? But remember, I just told you, there are no humans in this conversation. So if everybody's been on a data center tour at Google or whatever, you don't see any humans walking around, right? This is all done with computers. Okay? So with that, hopefully you learned a little bit about economics and think about what economics means and business models mean if you're going to go build a company or go work for a company. The second talk I want to do is on cloud computing. As I said, cloud computing for your Facebook friends. I'll start by telling you a story. So this happened a couple years ago. I am in a meeting with 6 CIOs of one of the largest healthcare companies in the world. And so we're doing introductions around the room. And my name's Bob. Bob, what do you do? I'm working on a strategy to move to the cloud, right? What's your name? Mary. Mary, what are you working on? Oh, I'm working on a strategy to move to the cloud. Okay, all 6 CIOs, every one of them. They're working on a strategy to move to the cloud. So I looked at them and I said, what does that mean? And they go, well, we're really not sure, but we're working on it. So I actually wasn't there to talk to them about cloud computing. So I said, let me take 10 minutes and let me give you a framework to think within so that you can figure out what it means to move to the cloud. So I'm going to do this with you guys in slightly more time. And I'm going to start, this is buzzword free, I promise, right? I'm going to start at the top, which is we all use consumer application cloud services, right? So whether that's Twitter, Facebook, or I log into my favorite banking website, I'm using consumer applications, right? Now, it didn't always used to be this way. We used to get software, install it, manage it. So I'll tell you a small story. This is 2 years ago. One of my Stanford kids says, I really need to understand this cloud computing thing. And I said, okay. So we're out to breakfast. And so I start the very same way. I go, we're all using consumer application cloud services, right? Didn't always used to be this way. And she looks at me, she goes, oh, no. I've heard of this. It's called a floppy disk. Now, I know the young people in the room have no idea what these look like. Can you go find one, Bob? So, once upon a time, we used to get software on these little disks, and we used to put them in our PCs, like 7 or 8 of them, and install software. Nobody does that anymore. In fact, I have to explain to you guys that that's how it used to be. All consumer applications have moved to being cloud services, okay? I just quickly ran you through the idea that many business applications have moved to being cloud services, right? So whether that's traditional companies or, or born in the cloud companies, tons and tons of applications, business applications delivered as cloud services. Now, all these guys use the original cloud, which is a network cloud service. Now, once upon a time, this was also for old people in the room, they'll go, oh yeah, I remember this. There used to be words like SNA and BNA and HDLC and X25 and SDLC. These were all communication technologies so that corporations could go build networks. Nobody does that anymore, right? Everybody buys IP/MPLS-based networks from a variety of service providers on a global basis, right? So on this side of the fence, we're all the way over, right? Everybody buys or consumes network cloud services. Now, the guys that built network cloud services said, hey, wait a minute, right? I have to have a room to put my switches and routers in, which are cold, have big guard dogs out front, and are not located on a fault line. So they went, well, if I can put switches and routers in there, I can also put computers. And so a whole generation, really starting in the early 2000s, of data center cloud services came into existence. Many of them, weirdly enough, have been bought by network companies. Savvis actually was acquired fairly recently by CenturyLink, Terramark by Verizon, et cetera. Okay? Now, I'm not going to spend a whole lot of time on data centers. It's a whole interesting conversation. But I'm going to point out one interesting thing. So if you're thinking about carbon tax and carbon as a future issue, one of the things you start to speculate on is, well, at what point in time does a business, is the smokestack of the business the computers, right? As we move to being information-powered businesses, when does that happen? Well, so I made up this ratio. It's called servers per employee. So for any of you guys at work, you could go back to work and say, okay, how many servers do we have? I don't care, big ones, little ones, virtual ones, add them all together, divide by total number of employees, contractors, etc. Okay? Now, I've done this so many times, I will tell you I already know the answer for most of your businesses. But it turns out the U.S. government actually tracks this number for developing economies. So if you're in India, the number is 0.02, and if you're in Brazil, it's 0.04. Why? Because if you think about it, if I'm a developing economy and my servers per employee is 0, the chance for global economic development is about 0, right? So this group of companies sitting right in here between 0.5 and 1 server per employee, anybody want to guess who these are? Okay, these are my friends that do enterprise applications. So this is Salesforce, NetSuite, SuccessFactors, etc. Now I'll tell you, because I've done this so many times, most corporations in the world sit between 0.5 and 0.1. Which should now lead you to an interesting question. What's that? Google, Facebook, right? Google's actually, last estimate I did at 50 to 1, Facebook's at 30 to 1. These are actually probably low estimates at this stage. Now, is that because they're operating inefficiently? Which is one way to look at this. So anyway, I want you to think about it. So the whole thing with the cloud became really big when Jeff at Amazon came out with AWS, what we call AWS today, right? Delivering compute and storage as a cloud service. The reason for this is applications are only interesting to certain groups of people, like CRM is only interesting to salespeople, but compute and storage applies to everything, right? So whether it's the new kids on the block or the existing players, the Microsofts, the IBMs, the Rackspaces of the world, right? Everybody and their brother is in, which is why you cannot go through San Francisco Airport, sit and watch the Masters, or go to a ball game at Fenway Park and not see a cloud computing ad, right? Because it's all about the massive amount of compute and storage that can and will be delivered as a cloud service. Now, one of the things I want to point out to you is the innovation that the guys at Amazon made was not a technological innovation. It was not a technological. Virtualization is required, yes, but it was not a technology innovation. It was a business model innovation. Okay? The ability to buy a computer for 12 cents for an hour and give it back to you, right, has enabled a whole group of applications to come into existence, which I will tell you were technologically always possible, but economically were not. Okay? So I'm not going to go through all the examples, but I'm going to give you 2 just for you to think about. So the first is high growth applications. So how many in here know who the Gilt Group is? Yeah, and it started out, for those of you who don't know, by selling high-end women's fashions, like Prada handbags. So you could go to and register for these flash auctions and buy a product handbag for $12,000 as opposed to $18,000. Now, by the way, the first time I heard this, I was like, who the hell would ever do this, right? Well, okay, what do I know? This business actually in 2.5 years grew to be over 300 million, right? Now, think about this. You guys are technical people, right? If you're the IT department at the Gilt Group, what's going on is you're going from 0 to 300 million in 2.5 years. I tell you, every day you're walking in the boss's office going, I need another server, I need another server, I need more disk, I need another rack, I need more power, I need another data center. Right? I mean, and for people who've done this, yes, you can do this. It's very painful. These guys never did that. They ran on compute storage cloud services from day one. They just added more instances as they needed, right? Which is why, and you're very well aware of this, I'm sure, every startup in Silicon Valley who thinks they're going to be the next Facebook, Google, whatever, right, is already running here. This is already fait accompli. Okay? Now, let me give you another example of an application, a periodic bursty application. So what does the end of February, the April 15th, February 14th, and the end of January have in common? Okay, April 15th is tax day. Several years ago, the Intuit website fell over on tax day. 300,000 people could not file their taxes. February 14th, Valentine's Day. You may never have thought about it. It is the #1 day for e-cards on the planet because you do not send them on February 13th, and you certainly don't send them on February 15th. So all traffic moves to one day. Okay, end of January, Great American Holiday. It's always interesting which audiences, what answers you get. Super Bowl Sunday. Super Bowl Sunday. So this has actually happened twice, amazingly, right? So the story I'm going to tell you is about Denny's and Dockers. So Denny's and Dockers ran multi-million-dollar ad campaigns to drive you to their website to, in the Dockers case, get a free pair of pants, in the Denny's case, to get a free breakfast. Can I say it again? Multi-million-dollar ad campaign. What you don't know is within 60 seconds of the multi-million-dollar ad campaign for Dockers, the website fell over. Right? Did you want to be the IT guy there? I don't think so, right? Okay, now why I tell you this story? Well, this problem is easy to solve, right? It's called high volume load testing, right? What do? You go buy servers and you put them in New York, San Francisco, LA, you build up synthetic transactions, you bombard the systems with it, you find the performance problems, which, by the way, it is rumored were found on the Denny's website the week before, right? And you correct these. Now, think about it, right? Buying a bunch of servers, finding space for them, et cetera, enormously expensive to do. Well, no longer, right? So today, right, do I want 100 servers in 10 different locations for an hour a day a week? Easy, right? So my point, technologically always possible, only economically now possible. And so this thing about economics is driving, and we'll get to that, I believe, a whole new generation of applications. No. Let me finish this by talking about two other major components. So the guy that won the war last time around won the developer. That was Microsoft. The war is on again to win the developer. It's occurring in all sorts of different dimensions, from the traditional, so Microsoft and their Azure stuff, all the way to very, what I think of as verticalized environments, so Force.com, NetSuite, SuiteCloud, etc. So for all of you in software development, in fact, I just spent the morning talking to a bunch of guys about Go, which I was totally amazed by. But anyway, this whole new world of software development where, and the important point is, the time from when I build a piece of software till it's in production is no longer years or even months, right? It's weeks. And the change and shift in the type of way and I build software in a world where I'm collapsing that time is dramatically different. And there's whole new environments being created all the time in this area. The other major area is operations management. Remember what I said about, right, where's the cost structure in any of these IT shops? It's the management of security, availability, performance, and change. I don't want to use humans to do this. I want to use computers. So a lot of software companies have come into existence to let you solve these problems with computers, not humans. Trivial example of this is spam filtering, right? Once upon a time, you want to build a consumer website, you have to have spam filtering software. You'd buy it, load it up on your PC, manage it, etc. Nobody does that anymore, right? They buy it from MessageWay or Symantec or whomever as a service. This is going on in many, many, many other areas. Okay? So with that, I took you all the way to the top, to applications. And so remember, my friends at the healthcare company, I said, okay, here are 7 ways you can move any application to the cloud. So I picked on Siebel just because it's easy to pick on. So if you have a Siebel application, you could move to a new network cloud service that has better connectivity, lower cost, higher reliability. You could move to a new data center cloud service that has colder air and bigger guard dogs. You could move to a compute and storage cloud service and let someone else manage the security, the availability, the performance of the compute and storage. You could re-implement, this has actually already happened, you could re-implement that application because you never used much of it in a new software development cloud service. You could take your traditional application and manage it in a completely different way. You could move, number 6 is almost every existing traditional player is now going, yes, I will manage the software I sold you. In this case, that would be Mother Oracle. Or you could move to an entirely new application, whether that's Microsoft, Salesforce, or whomever. Okay? So I said, look, go through your entire portfolio, and you can now move from a strategic intent to a tactical plan. Okay? So with that, I'm going to just touch on economics one more time, and then I'm going to wind down and talk about next generation apps. So just so you can think about this, you should know a little history. So this is the old people talking. So I want to ask you a question. This transition from, let's call it mainframe computing, which most of you have never heard these names like Unisys and Sperry and Honeywell and all that. You've heard of IBM, right? This transition to move to what you could think of as client server, right, happened basically in the 80s through the 90s. I always ask people, I say, well, did that transition occur because Unix was a better operating system than MVS and VM? Did that transition occur because Oracle was a better database than Kix, IMS, DB2? The answer was no, it wasn't. The transition occurred because it was economically a hell of a lot cheaper. And that hell of a lot cheaper, right, also drew a hell of a lot more software developers into the world. So people early on started going, okay, I'm going to take my Microsoft PC and I'm going to go write a little VB app because those guys in IT can't handle, changing another mainframe-based app, etc. So the transition occurred here was dominated by a transition from economic perspective. So I want you to be clear that that's what's about to happen here, is a transition all because of a hugely different economic. Why am I saying that? What is the economics? If I just, remember I said I'm talking about compute and storage. If I just talk about compute and storage, it's not, a lot of people talk about the cloud as, oh, this is a CapEx, OpEx conversation. It's like, what does that mean, right? What it really is a conversation of is who's going to manage the security, the availability, the performance, and the change of the compute and storage, the data center, and the network. If you're going to buy compute and storage cloud services, you're saying somebody else is going to do this. And by the way, hopefully someone's going to do this better than me. Because, and I'm absolutely certain at this stage, the cost structure, even of compute and storage, is at least 4 times the purchase price of the box of that server you're seeing there. So if you think about it, again, over a 4-year horizon, 16 times the purchase price. The hardware could literally be free. It doesn't matter. Your cost structure is hugely consumed by this. And just so you can think about one aspect of this, everybody likes to talk about security. So I'm just going to talk about security management very simply. So I tell people, I go, at the end of the day, security, a lot of people like to talk about, how high the walls are, or, how thick the bunkers. I said all security at this stage starts from a central thing, which is, do you have a hardened environment? What do I mean by a hardened environment? All I mean is you have no bad software in the system and you have all good software. That's it. And if you're not sure about this, there's some guys that run centrifuges in Iran who can explain it to you, right? Nobody got into those centrifuges with AK-47s or anything. They came in through software. We know this is the huge thing, right? So this is a single application. I had some friends do this, and I said, how many security patches were released to the infrastructure of that single application during 1 year? It turns out it was 137 security patches. Now, I can guarantee you, in most people's installations, none of these have been applied to the systems. And so at the end of the day, the cost for doing this by hand, very expensive. In the end, somebody's going to figure out how to automate the hell out of this and really take a step in the whole world of security from my point of view. Okay? Just to give you why does it cost something. So I'm going to end this by telling you we're still very early days in the world of compute and storage. So last year, the industry sold 8 million servers and 28 million terabytes of disk. Okay? If that had all been sold as a cloud service, it would have been worth $231 billion. Which means if this year we sold the same amount on a global basis, the market would be $462 billion, and you can do the math for the third year. Anybody know what Amazon sold last year? Amazon was at $6 billion. There's enormous. We are very early on in this move to consuming compute and storage as a cloud service, right? And my belief system is what we're going to start to see is increasingly specialized compute and storage, specialized by performance, by location, by security, by availability, by change. Okay? So I'm going to get ourselves to the end and go, I know the Amazon guys fairly well, so when I went to teach a class at Tsinghua, they gave me $3,000 worth of computer time. Okay? So I walked into class kind of like this. I said, well, we got $3,000 worth of computer time, which basically will buy you a server in Northern California, Virginia, or Ireland for 3.5 years. So they all looked at me and went, so what? I can have a server in Beijing for 3.5 years, right? I said, or $3,000 buys you 10,000 computers for 30 minutes. Nobody's ever been given 10,000 computers for 30 minutes. And now the question becomes, and this to me is the big interesting question in front of us, is not this, let's migrate existing applications, but what are we going to build new that we've never been able to build before is the question. And so I'm going to suggest what the answer might be. I'm going to talk a lot about things. I've been spending a lot of time with guys at General Electric and some young startups, which one of them is here, in this whole space. You're very well aware of this whole Internet of Things from the consumer side, right? Whether that's Apple Watches or Fitbit or whatever. But what I'm going to suggest to you is what is even more amazing is what is going to happen in the rest of the economy. And this is being driven by something I think people don't actually spend a lot of time thinking about, which is, yes, we're able to miniaturize computers, and put them on tractors or whatever, faster and easier than ever before, ARM, whatever. That's fine. Yes, true, right? But the big deal is we got sensors out the wazoo, right? People are building tons of sensors. I mean, and that's the sensors for the things that humans can sense, right? Like touch and stuff like that, but also things we can't do, like carbon dioxide and pressure and all these other things. And all these sensors are becoming lower and lower cost structure to be able to put in place, okay? Now, what is that going to mean, right? Well, let me just give you a couple of examples of what we've already seen. So in the construction rental business, there is a company out there who rents construction equipment. They have 425,000 pieces of equipment in the field. This is forklifts, scissor lifts, generators, right? All this stuff. They today instrument these. They only get data from those things once per hour. Okay? Just once per hour. Now, I did the back of the envelope math. Interesting thing to think about. The NASDAQ, where all stocks get traded, right? How many transactions, how many events occur per day there? I'll do it for you. It's about 10 million. About 10 million transactions, about 10 million events. 425,000 things giving you data just once per hour is the same volume as the NASDAQ per day. These guys are getting ready to move to once per minute. So they're going to be generating data at 60 times, 60 NASDAQs per day worth of data. Amazing. Utilities. Lots of you are familiar with smart meters, right? So down in Southern California, one of the largest deployments of smart meters has 1.5 million of them online. If you go down and you talk to them, which I have done, what you'll discover is they only pull data from about 10,000 of them. Why? They don't know what to do with it. These guys have transformers, very high-end pieces of equipment, which if you listen to them, they will tell you the type of data coming off of these look like a blood test. So they've got gas diagnostics coming off this stuff. Let me give you one last example. There's a project being run right now in the Southeast using something, actually it's interesting. Any of you guys ever heard of a synchrophaser? Ooh. Okay. So a synchrophaser, which I just learned a couple weeks ago, is basically a device that lets you see how out of phase the power is at any point in the distribution network. So they deployed 150 of these in the network just as an experiment. These puppies are giving off data once every second. They're headed to doing it 3 to 4 times per second. If you do the back of the envelope, this is 77 NASDAQs worth of data coming off only 150 synchrophasers, which is basically just a pilot from the standpoint of the power grid. Okay? Ag. We were just talking about ag. So I just got introduced to this. This is the age-old thing of every once in a while talk to your seatmate when you're in an airplane. So I was flying back from Chennai and decided that we'd just sit there and drink for the first part of the trip. So it turns out I'm sitting next to a guy who works for AGCO. How many of you guys have ever heard of AGCO? So AGCO is a $9 billion tractor manufacturer, right? So those of us in the U.S. have heard of Massey Ferguson as a brand that they own. So they own all those brands on a global basis. If you've never heard of the idea of precision agriculture, they've been working on precision agriculture for a while. Let me explain it really easily, as it was explained to me. He goes, well, have you ever painted your wall with a roller brush? I go, well, yeah. He says, well, if you paint your wall and you go like this, and then you go back over the same spot, you just took 2 times the amount of paint and doubled the amount of time it takes to paint your wall. I go, well, yeah. He said, that's precision farming. So purely based on location information, and as people have recognized, they built the automated car in the farm before Google, right? They're actually already doing this. Today, these guys, AGCO, have 25,000 implements instrumented over the past 3 years with data sitting in the US and in Europe, all ag data. And the level of stuff people are starting to think about, like, well, I can put this plant here or put this fertilizer here, but not here. I mean, that's the next generation of what's starting to happen in ag. And then I'll just give you another example of an awesome amount of data sitting out there. So this is from one of the largest internet service providers who has probably north of 5,000 routers in their network. You want to guess how much data is coming off of this per day? 1.8 terabytes. This is just dwarfing anything you can possibly imagine. So I think we're at the beginning of moving from what we have been working on up until now, which is people-generated data. So most of the data that's sitting inside computer systems today is because of us, right? We bought something, we took some cash out, we hired somebody, we fired somebody, we're sitting there at that terminal typing away, right? That's 9/10 of the data. And so what we had to do is we had to come up with a way to collect the data because I was going to do something with it. And do something with it meant track my sales force, do e-commerce, whatever, right? This is all the traditional software that we built up until now. Now, after we had this data, a whole group of companies emerged to learn from it, right? So the whole Cognos, business intelligence community arrived because now we had some data that we could cut, slice, and dice, right? What I'm going to postulate to you is we're headed into this world, which is not data generated by humans, but data generated by things. And it's enormously different. I actually, just back of the envelope, created the number 30 billion. Turns out Gartner was saying this number. The only reason I did it is I went, well, if you say there's 300 million people, and you say each one of us, we have a car, we use electricity, we buy food, so there's probably 100 things per person that we touch. So that's how I get to 30 billion. Now, the point that I want to make with you is we're going to have to figure out how to collect this data. A lot of the stuff that's being done today, both in the networking front, data cleansing, aggregation, the word you've heard words like Spark and Hadoop, things like that, all fit into how are we going to collect this data. But then my postulation is before we figure out what to do with it, we should learn from it, because this is too much stuff. I just quoted you tons and tons of things where humans have no capacity to do this. So we're going to have to learn. Once we learn, we can do something about it, right? So just to give you a sense, so you can go, well, what kind of data does this look like? This is actually data coming off a generator, just to show you the kind of data coming off of these things, okay? So today, really, the only thing that's been going on, if you go sit in a data science class or any of that sort of stuff, is largely human learning. Humans trying to visualize, cut, slice, and dice this stuff, right? It's largely because we're coming from the old world of trying to do this with human-generated data, which is a lot less, right, than what we're seeing here. And the postulate I have is we've got to move beyond, and we've got to start letting machines tell us stuff about this, not humans. So for those of you who haven't spent a lot of time in machine learning, I say go spend time doing this, right? So whether that's static machine learning, right, which you learn about things that are not changing based on time, or dynamic machine learning where you're starting to learn from things that use time series data or data that's changing by the minute, by the second, by the hour, right? There's a whole field of math and science based in this. If you're at all interested in this, there's a guy sitting up here named Nick. I'll point at him. Nick's been doing a lot of work in this area. It's enormously fascinating. So what could happen here? So this is, I don't know if you saw this. This is a funny example. It just came off the internet. So most people, by the way, and General Electric talks a lot about preventative maintenance. A lot of people think about this problem from I can maintain the jet engine faster or better. But there's so much more that we can do with this. So this is actually an interesting case study. So they instrumented cows. They put pedometers on cows. Now what they came to discover is the level of activity of a cow basically can predict at what point in time, if it's a girl cow, you should inseminate the cow to get a female cow versus a male cow. And they used learning to try to figure out what point this was. Turns out it's 36 hours after the high activity. And so now they have these cows on pedometers, right? So that's why I go learn. Once you learn, meaning, after 36 hours, right, it's going to be a male. Before 36 hours, it's a female. Okay, now I can do something about it. Of course, I don't have to automate any of this, right? Transportation. This actually is an example of the guys at Splunk just gave me. So New York Air Brake, which is a big provider of services for the locomotive industry. So they basically instrumented 18,000 locomotives out there and just tracked, right, what the humans were doing, right, in terms of which routes they chose, when they stepped on the accelerator, et cetera, et cetera. They aggregated all that data, gave it back to them, and said, here, let me teach you how to be a better train operator, right? So locomotion, insurance. So this is a hugely interesting space. Once upon a time, right, how do I determine the insurance for this new Corvette? Well, you're 16 years old, and you're driving a red Corvette. And it's got Z06 package on it. Oh, well. $1,000 an hour, right? Okay, now if you think about this, not only can you instrument the cars, and so you get some of you guys have seen this progressive thing, which is a very rudimentary accelerometer. That's all it's in it. But there's a just spent some time with the guys at Continental AG and their research labs. Right now, want to guess how much data can come off of a car per day? 15 gig today, right? So if you think I can get the data about the car, I can get the data about the environment. So there's a company up in Berkeley called Census Networks. They're actually instrumenting intersections, roads everywhere. So now I can see what traffic patterns there are. I know what the weather is, right? So now all of a sudden I can start shifting even business models because I can say, well, actually, I know that you only drive, on roads which have no accidents on it, and you're always driving on a sunny day. Okay, your insurance just went to a penny a month or whatever, right? And that's just a trivial example. Healthcare can be revolutionized in so many different ways. There's actually a project with one of my professor friends at Carnegie Mellon back in Pittsburgh on the usage of data to do diagnostics for Parkinson's. Just a trivial example of what can be done with this stuff in the healthcare space. So I'm going to end, see Stephen introduced me this way. So I've been working with actually the guys at Carnegie Mellon in Africa on the concept of building an internet laboratory for things, right? Now, why? Because if you look at it on a global basis, right, growth in an economy is always growth in population. These are all heavily related. You never thought about it. So where is growth occurring in the world right now? Okay, let me tell you a couple answers. It isn't. It is not Europe, net of migration. It is not Japan. It's not even China. China's aging, right? The growth areas on the planet are Africa, Latin America, and Southeast Asia, right? Africa, for you that have never thought about it, by the year 2040, 2050, is believed to be 25% of the world's population will be in Africa, right? Nigeria will actually pass China in population. Fascinating to think about, right? And if you think about growth of global economies, the growth of the global economy will have to be based in growth in infrastructure, growth in power, water, health care, agriculture, right? The fundamentals of any economy. And I'll give you the last one. So if you're going to build the next generation power system, the next generation farm, the next generation port, are you going to do it the old-fashioned way? Hell no. This is the old, why did, China went to cell phones, never had landlines. You would not do it the old way. You would build it with highly instrumented things, whether I'm in a power system, on a port, in a farm. And so I think what we're going to see on a global basis is dramatic shifts, right, to next generation technologies, right, based in this huge uplift in infrastructure on a worldwide basis. So with that, hopefully I taught you a few lessons for long life in your professional life. Got you thinking about things that you should think about in the future. If not, I gave you 10 lessons for long life in your personal life. So with that, I'll take a few questions if we've got time or how you want to do it. Yeah. I'm happy to do it. And then I'll get out of here.
You want to hit the microphone just so that people online can.
So one of the biggest challenges for building an enterprise startup is the initial customer acquisition. So my question is, what is your strategy for young startup to really initiate the first ever conversation with the CIO or any other strategy about initial customer acquisition?
You want to hear my talk called Sales for Nerds. I can come back and tell you. I've actually spent a lot of time on this question. Let me just give you a couple things for you to think about. So there are a couple attributes of high growth enterprise software companies. So one of the attributes is that they generally deploy lightweight business processes, not heavyweight. Lightweight meaning pretty much everybody does things the same. That's why collaboration has worked, Salesforce tracking has worked, hiring and firing. These are relatively, everybody does them the same way, relatively speaking. But process manufacturing is not like that. It's very heavyweight. So no one knows how to build a piece of software where I can make 2 configuration changes and build jet fuel instead of Coca-Cola, right? So that's where, 1, lightweight versus heavyweight, right? 2 has been that growth has occurred to people who focus on the worker, not the enterprise, which is a weird thing to say. So I'll give you 2 examples. So I actually was on the advisory board for WebEx, right? So WebEx and Salesforce both are great examples of ultra-high growth enterprise software companies, right? So what was common about that? They could sell to the worker, which meant 2 guys in support at Electronic Arts could decide we're going to do a WebEx session. I didn't have to go to the boss. I didn't have to go to the CIO, nothing, right? Salesforce, same thing, right? 2 guys in Des Moines, Iowa could decide we're going to share our ACT database. I don't need to talk to the VP of sales, right? So this allowed much faster adoption rates versus if I'm forced to talk at the top. So I'll give you the counter example of this. So I had the CEO of Jive do guest lecture for me last year. So he said, great news, we won Citibank. Right? I thought, oh, good. Bad news, took 18 months. Why? If you think about it, if you know what Jive is, enterprise social networking software, right? Okay, so if I'm a sales group and I've deployed Salesforce, what am I going to use? Chatter, okay? Because it's already there. If I'm a big Microsoft shop, what am I going to use? Yammer. If I'm a big IBM shop in my manufacturing floor, I'm going to use the Lotus Notes variation of this. So the only way they could make a win was they had to go all the way to the top. And they had to force a global decision to go with their product. Well, by the way, if you do that, your sales cycle times go to 18 months. If your sales cycle times go to 18 months, most salespeople don't work for free. So you've now taken your cost structure up. So you must take your average selling price up. If you take your average selling price up, you elongate sales cycles. So the more you can focus on the worker and not the enterprise, you will get higher growth. And I have 3 more that I could take you through. But one of those things is really focusing on what are the attributes of the application that enable high growth. Then one can start to talk about how do I make an approach? Who do I need to talk to? What story do I need to tell them becomes the next part. But you have to have the first part first.
Well, I'll tell you what, in the interest of time, we're running a little long, but we have refreshments outside and people can grab Tim before he leaves at 3. So maybe we'll just finish this conversation just outside in the lobby where there's some food and drink.
Okay.
Let's thank our speaker very much. Fascinating talk. Thank you.